Hi everyone, today we are going to be introducing 3D or three-dimensional figures. Now, we did not provide you with this paper before we left school, but I did upload a blank and a filled in or key to our Google Classroom page. So if you are able to print, you could print a blank and follow along and fill this in with me. If you are not able to print, then just grab a piece of either plain or lined paper or even the back of an old worksheet just so that you have a place to take these notes, just the bare bones of these notes, and have something in front of you so that you're writing and engaging your brain. Okay, so for our vocab for this part of the unit, we have the face, base, vertex, and edge of a three-dimensional figure. So the face of a three-dimensional figure is any of the flat or two-dimensional surfaces, including the bases. So if we take a look at this box, the big front of this iPhone box, that's a face, okay? The side is also a face. The back is a face. This is a face. This is a face. This is a face. So any rectangular box or cube is gonna have 6 faces, okay? The base is different. The base of a three-dimensional figure names the shape. So if this is a base, this front and the back, well, that's a rectangle. So this is a rectangular prism, okay? So it names the shape. If it had a triangular base, it would be a triangular prism. If it had a hexagon, it would be a hexagonal prism. A prism has 2 bases which are parallel to each other and never touch. So for example, the front of this iPhone box is never going to touch the back side, right? It would never touch that. A vertex is the point or corner of a three-dimensional figure. So this is a vertex. This corner is a vertex. Vertex, vertex. There are 8 vertex or vertices on a box, like a shoebox or the box for this iPhone, right? There's 8 of them. There are 8 corners. An edge is the line segment that joins the 2 faces. So this line segment, that's an edge, edge, edge. Wherever 2 edges meet, there is a corner or a vertex. Okay, so you're able to count all of those properties, qualities, or characteristics of a three-dimensional figure, whatever you want to think of them as. So below here it says brainstorm some 3D figures that we see every day. We see cubes. Definitely if you play with a Rubik's Cube, right? They're all the same size. A cube is made up of 6 faces that are all squares. They're all congruent or equilateral. A rectangular prism is like a shoebox. Pyramid you see in the world. A triangular prism would be like a tent, okay? So each 3D figure has specific properties, qualities, or characteristics. All of those words are synonyms. You could just choose one. All right, so below that, I have a cube and a shoebox or a rectangular prism. So we're gonna label the vertices, edges, faces, and bases of these figures. So a vertex is all these corners. If I try to zoom in on that, you can see I did a little blue dot at each of the corners. Okay, so that's a vertex. A cube has 8 vertices. 1, 2, 3, 4, 5, 6, 7, 8. All right, those are the vertex. Same over here with the rectangular prism, also has 8. All those little corners, there's 8 of them. In blue, the edge is the line where the 2 faces or bases meet. So these are edges. So we can also count up the edges. And then the base, this is a base, well, this is also a base, this parallel portion. I didn't label that, but that's also the base, okay? They are parallel. Rectangular, rectangle, that's a rectangular prism because it has 2 bases that are parallel. Same over here. This has a square base on the cube. That's a base, that's a base. And then this is a face. All the other flat surfaces are faces. Is a base a face? Yeah, technically, but for the sake of naming the figure, we differentiate it and say that's a base, that's a base. Square base, rectangular base, they're parallel to each other, okay? So how are cubes and rectangular prisms the same? What makes them unique? They both have 8 vertices, 12 edges, and 6 faces, okay? They both have that, so that makes them the same. The cube has congruent faces and equal side lengths since its faces are all made of squares. So that would be what makes it different. All right, So if you printed this, you're gonna have a really nice grid to fill in. If you were not able to print it, no big deal. Just try to draw yourself out some of these shapes. So up at the top, let me adjust this real quick. Up at the top, it tells us the shape, or shows us the shape, asks for the name, the faces, the bases, the vertices, and the edges. And we're gonna count these all out. And I did try to color code these for you. So taking a look at the first shape. Okay, so we have a cube. How many faces does the cube have? Shaded in blue. Well, that was kind of tricky to do because if I shaded in some of them, you wouldn't see the rest of them. Okay, but you can see it has a side, a back, another side, and a front. So it has 4 square faces. And then the bases I colored in, it says it's shaded in red, but I liked this magenta pink color better. So it has a top and a bottom. Those are 2 square bases. Now, obviously with a cube, if you rotated it, the base changes. Not a big deal. It's still gonna be the same. For the vertices, color those in green. There are 8, and the edges, there are 12. So you can see, if I kind of zoom in a little closer on the cube, you can see the green dots are the vertices and the purple lines are the edges. All right, this next guy is a rectangular prism. It has 4 rectangle faces, 2 rectangle bases, 8 vertices, and 12 edges. Same as the cube. The only difference, why it's called a rectangular prism and not a cube, is because there are rectangles, right? Notice 1, 2, 3, 4 rectangles that are all congruent or equilateral, and then there's 2 squares on the sides, okay? It doesn't make the whole thing equilateral or congruent like a cube. All right, triangular prism, red, the reddish pink magenta colors, these are the faces. These triangles are what are naming this triangular prism, okay? They're parallel to each other, they're equal. So they're of the same size and shape, congruent, equilateral, right? There are 3 rectangle faces, 3 rectangle faces. So you'll notice with the blue, I tried to make the lines going in one direction. So there's this side of the tent, there's this side that's going this way, and then there's the bottom. So there are 3 rectangle faces. And then we have 6 vertices and 9 edges. Okay, so the 9 edges are in purple. They're outlined in purple. And then the green dots are in green. Okay, so the green is the vertices, 1, 2, 3, 4, 5, 6 vertices. And then the edges are in the purple color. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 edges. All right, the shape below that is a rectangular pyramid. Almost looks like a square pyramid, but this one is a rectangular base. So we call it a rectangular pyramid. It's named for its base. Notice the difference is that it all comes together at one point or vertice, okay? So all of these triangular faces come together at one point. So that's the difference between a prism and a pyramid. They're both named for their base. This is a rectangular pyramid. This is a triangular prism named for its base, but there's only one base when you have a pyramid. So rectangular pyramid is its name. It has 4 triangular faces, 1 rectangle base, 5 vertices, and 8 edges. So let's look back at it for a minute. You'll notice there's 1, 2, 3, 4, 5 vertices. The edges are hard to see. So there's 1, 2, 3, 4, 5, 6, 7, 8 edges. Now the one below that is a triangular pyramid. Notice the difference. This is a triangle, that's a rectangle. It's named for its base. So triangular pyramid has 3 triangle faces. 1, 2, 3. This one on the side, this one on this side, and then the one in the back. 3 triangle faces, 1 triangular base, 4 vertices still. 1, 2, 3, 4 vertices, and then the edges in purple, there are 6 of them. 1, 2, 3, 4, 5, 6. So I would definitely recommend trying to color code your notes in some way so that it will help you differentiate and count. All right, below here, if you printed it, things we notice about the difference between pyramids and prisms. Prisms have 2 identical parallel bases. Pyramids have 1 base and the triangular faces that all meet at 1 vertex or point. Zoom out here. What makes a triangular prism unique? 2 triangular bases that are parallel to each other. And then below that, to summarize today's lesson, we learned to count faces, bases, vertices, and edges of 3D figures. We also learned the differences between prisms and pyramids. So again, this blank and filled in are going to be uploaded to Google Classroom. I would definitely either print them if you can, make your own little chart in a separate piece of paper. I'm going to make a really big anchor chart for the classroom for when we get back for next year, unfortunately for you guys, but at least we'll have it, and that way you'll know how to name figures, how to count faces, bases, vertices, and edges. Okay, please email us if you have any questions. Make sure you watch the Khan videos and practice the Khan assignments as well. Have a great day, everybody. Bye.